Hello everyone. Today I'm going to start a new lecture series on a very interesting subject, that is fluid mechanics. So the target audience for this subject will be the BTech students and also those who are preparing for some competitive exams and want to clear their basics. In this lecture I will be giving you just the introduction of the subject, and and the last I will be providing you the some PDF notes. So just listen to the lecture and clear your basics. So let's get started. Fluid mechanics. Fluid mechanics is basically the branch of science that deals with the mechanics of the fluids. In this subject, we will be going to study the fluids that are either in rest or in motion. Okay. Now, let's first go to the classification of the matter. We all have earlier studied that matter is classified as solids, liquids, and gases. But now, from the FM viewpoint, we classify matter into two parts. One is the solids and the rest are fluids. So, fluids comprises of both liquids and gases. The basic difference that lies between the liquids and gases are their packing. That is, the liquids are relatively more close packed and have higher cohesive forces between them. Now the question arises, what are these cohesive forces? Basically, the cohesive forces are the attraction forces that are acting between the molecules of the same substance. One more thing, there are also the adhesive forces. These forces are the attraction forces between the molecules but of the different substances. So don't get confused between the cohesive and the adhesive forces. Now let's discuss what is a fluid. From the technical viewpoint, we can say that a fluid is a substance which can't resist any shear stress when at rest. So it means even a small amount of shear stress will lead to the deformation in the fluid. Okay. Now let's understand what a shear stress is basically. So first let's discuss about the stress. Stress is basically the internal resistance of a body when it is acted upon by any force, sorry, when it is acted upon by any force per unit cross-sectional area of that body. So it is denoted by the Greek symbol sigma, and its units, SI units, are Newton per meter square. So this force can be acting either perpendicular to the surface area or tangentially to that surface area. When these forces are acting tangentially to that surface area, the stress that will be acting is known as shear stress. Symbol for that shear stress is tau. So this shear stress will be causing the sliding of one layer over the other layer, but in the opposite directions. There are many examples of shear stresses that we can discuss, but I will be giving you some few examples from our daily life. Like, have you ever thought that when we walk or run on the ground, we apply the shear stress? Also, when we cut a paper with a scissor or cut our hairs with the scissor, we again apply the shear stresses. Even when we are using our mobile phones, when we slide our fingers to use the touch screen of that phone, we apply shear stress. And there are numerous number of examples of this shear stress in our daily life. Here you can see that there is a lap joint of the two plates that are riveted together, and the force F is applied at both the ends of those plates. When we will be examining this section of this rivet, we will find that this section will be undergoing a shear stress which can lead to its failure. Okay. Now this subject has a wider application even in the natural phenomena and in the technological systems also. So I will be discussing some few examples, like, have you ever imagined why the ball in the cricket spins? The answer is with the this subject, fluid mechanics. Fluid mechanics says that there is a fact named that Magnus effect, due to which the pressure difference is generated between the sides of the ball, due to which the ball moves from the higher pressure side to the low pressure side. Also, we apply this subject in the aerodynamics, in the canals, dam systems, and many more applications are there. So these are the notes. You can go through them. If you like my content, so kindly like, share, and subscribe. Thank you for watching.